Now in this chapter we're going to be talking about four-stroke engine diagnosis. Diagnosis can be said to be the process of elimination. By eliminating the components that are good, it can quickly be established what's actually malfunctioning. Now there's not always a published structured order of diagnosis. In many cases, a diagnostic strategy must be established. Each technician must be able to develop a logical order of diagnosis. The logical order can be applied not only to the engine, but to any system diagnosis. Remember to always refer to the service publications for information on system information, specifications, diagnosis, and repair procedures. Now, let's talk about that strategy again. The first thing you want to do is verify the malfunction. Can you duplicate the malfunction? Go with the atom, if it ain't broke, don't fix it. It's nearly impossible to do a diagnosis on a malfunction that can't be duplicated. And remember, being able to duplicate a malfunction will give you a good idea of where to start your diagnosis. And don't forget the basics. First, has someone had this problem before? To find out, check the service bulletins. And also, as a guide, you can use the diagnostic flowchart. Then, run your tests in order of difficulty. What component should you start with first? Well, the simplest item. And then move on to the more difficult. And remember that the order of diagnosis isn't necessarily written in stone. The order that one guy follows might not be the order of someone else. This doesn't mean that one person is right and the other wrong, as long as the end result is an efficient, correct diagnosis. Now, to ensure proper operation of the engine, there are some basic requirements that may or may not be related to the engine itself. And those requirements include, but are not limited to, the engine's basic mechanical integrity, including the proper compression and valve timing. The engine must be supplied with fuel. It is delivered to the engine in various ways, such as with a carburetor or through the use of fuel injection. For more information on fuel systems, well, refer to the section in this video series on that subject. The engine requires an air supply in order to mix with the fuel to provide adequate combustion. The air-fuel mixture in the engine then has to be ignited, and this requires the use of electricity in the ignition system. Electricity is also used in the starting and the charging systems, so for more information on electrical systems, refer to that section in this video series. After combustion, the spent exhaust gases need to be safely discharged from the engine and away from the vehicle. The engine produces heat. The heat must also be carried away from the engine through a cooling system. Inside the engine, there's friction from the movement of internal parts. This friction causes heat and wear. The lubrication system is used to reduce this friction and wear. Now, in addition to the basic engine operational requirements, there are some other systems that can have an effect on engine performance. And when you're diagnosing engine-related performance problems, these related systems can't be overlooked. Now, these systems include, but aren't limited to, the propellers or impellers on a watercraft. Is the propeller or the impeller of the correct pitch? Pitch can affect things like engine RPM, the rate of acceleration, and the speed of the vehicle. Is the propeller of the correct diameter? Diameter can also affect engine RPM. Another example, is the propeller or the impeller made of the proper material? The material can affect, again, engine RPM and the rate of acceleration. Now, when we're thinking about ATVs, is the transmission of the correct gear ratio? The gear ratio can affect the engine RPM and the rate of acceleration. Now, are the engine controls properly adjusted? Improperly adjusted controls can affect top operating RPM. Now, let's talk a little bit about what engines in general need to run. Engine operational requirements begin with the mechanical integrity of the engine. The engine's ability to draw into each individual cylinder a fresh air-fuel charge, to compress it, ignite it, and then expel the burnt gases cannot be compromised. The basic requirements are, but aren't limited to, is the compression within specification. So a few questions you should ask yourself would be, is there enough air-fuel mixture getting into the cylinder in order to be compressed? Is the air-fuel mixture staying in the cylinder during compression? Remember, leakage past the rings can give you low compression, and so can leakage past the valves and leakage past the head gasket. Now, what if compression pressure is too high? That could be caused by combustion chamber deposits or an improperly modified engine. Either of those could cause the engine to go into detonation, which causes pinging, and then pre-ignition, and then you'd have major engine damage. The engine must also have the correct valve timing. Incorrect valve timing can cause things like low compression readings. Things to ask yourself there would be, are the valves opening? And are the valves opening at the correct time? You know the timing gears or the chain could be broken, and if they were to break, the engine may exhibit a very fast cranking speed. Now, something else to consider if the timing chain breaks is if you're dealing with an interference or a non-free turning engine, which means that on some you have a potential of the valves hitting the piston. And that means that if the chain were to break, the pistons would contact the valve and bend them. If the engine is a non-interference type or free turning, the pistons can spin independently of the valves and there's no danger of having a bent valve. Now, let's spend a little time talking about some basic mechanical integrity tests. We're going to use this boat over here and do our compression test. You ready for that, Chuck? Okay, let's go take a look. Thanks, Chuck. Hey, you look like you've lost some weight. Are those Richard Simmons tapes working for you? Hey, good stuff. Keep up the good work, buddy. Now, the different types of tests that can be done consist of a compression test, a cylinder leak down test, an engine oil pressure test, and vacuum tests. And in order to obtain accurate compression results, the following steps must be taken. First, all tests must be performed with a fully charged battery. A slow cranking speed can affect compression. Then the ignition system has to be disabled. And if it's not disabled, ignition system damage may result. Also, an open spark could ignite fuel vapors in the engine compartment and cause an explosion. So use the ground posts for the spark plug caps where applicable. Next, the fuel injectors need to be disabled. If they're not disabled, fuel vapors can get pumped into the engine compartment, and also the engine can flood from repeated cranking with the injectors spraying into the ports. So in order to disable the fuel injectors, hold the throttle fully open for a couple of seconds. And this will cause the engine to go into drown mode. This way, the fuel injectors won't fire when the engine is cranked, and a solid beep will be heard to tell you that the engine is effectively in drown mode. After that, you want to remove all the spark plugs. Spark plugs that are left in place can slow the cranking speed. Then the throttle needs to be fully open to allow a full air charge to enter the engine. Then we're going to install the compression gauge into one of the spark plug holes. Let me do that. Get set up here. There we go. Then what we're going to want to do is crank the engine until the peak pressure is reached. Next up, we have to install the desk cap, hold the throttle, and crank. Now record the reading on the gauge. Then you'd want to perform the same steps on the rest of the cylinders. And finally, compare the readings to specification. If a low reading is obtained, a small amount of engine oil can be added to the cylinder and the test be repeated. Now this would be known as the wet test. The oil will seal around the piston rings. If there's a substantial increase in compression, there could be a problem with the piston ring sealing. And if the pressure doesn't rise at all, then the problem could be coming from a leaky valve. Now let's take a look at some of the items that can cause low compression readings. In fact, let's go over to our cutaway here where I can show you the parts a little clearer. Now the parts that could be causing you problems is leakage past the piston rings, worn piston rings, excessive piston to cylinder wall clearance, leakage past the intake or the exhaust valves, a burnt valve, broken valve, bent valve, stuck valve, broken valve spring, worn valve guides, worn valve seats, an intake valve that's not opening, a worn camshaft lobe, a malfunction or a breakage in valve train components, or there's always the possibility of leakage past the head gasket. If there is leakage past the head gasket between the oil and the coolant passages, there's a possibility that there may be coolant in the engine oil and vice versa, because when the engine is running, the oil pressure is higher than the cooling system pressure, and when a warm engine is shut off, then the coolant pressure becomes higher than the oil pressure. Also, if two adjacent cylinders have low pressure, that could be the result of a blown head gasket. Well, that's a pretty long list of possibilities for low compression, but how do you go about isolating which one is the actual cause? The answer brings us to another test. And this is the cylinder leakage test. A cylinder leakage test can be performed to determine where the compression pressure is leaking. A cylinder leakage tester like this one here and shop air are what you need for this test. Now, even though there are a lot of things that could malfunction, there are only a few places where the pressure can leak. Let's go take a look at this cutaway here, show it a little better. It can leak past the rings into the crankcase, past the exhaust valve into the exhaust manifold, past the intake valve into the intake manifold, or through the head gasket into either the cooling jackets, into the crankcase, or through the head gasket into an adjacent cylinder. And just a note on this, if it is leaking past the valves, it may be a tight valve lash adjustment. So refer to the engine assembly procedure section of this video for information on that valve adjustment. The leakage tester checks the amount of air that leaks from a sealed cylinder. It's measured as a percentage. 10% leakage is a small amount, and 90% is a rather large amount. In order to obtain accurate cylinder leakage results, the following steps need to be taken, but remember, of course, that steps could vary slightly depending on what engine you're working on. Now, I'm going to work on this one here just for ease of operation. It's easier for you to see, and it's easier for Chuck and I to work on as well. Of course, always refer to the shop manual for the specific procedure for the engine that you're working on. First, the engine needs to be at operating temperature, and this will ensure that all the components are expanded to full size. If the engine doesn't run, that's okay, the readings will be accurate enough. Next, you want to remove all the spark plugs. I got one here. Next, you turn the engine over until the cylinder that you're testing is at top dead center on the compression stroke. In this position, it will ensure that all the valves are closed. And I'm going to give you a word of warning here as well. The piston will be forced down by the air pressure if it's not exactly at TDC. On a single cylinder engine, the crankshaft can be locked. On a multi-cylinder engine, you may have to apply air a couple of times before it actually stays at top dead center. And also remember to stay clear of belts and pulleys, as they will move if the engine turns and personal injury may result. So now, once you have the engine at TDC, you can adjust the leakage tester. First, you need to apply shop air. Then adjust the regulator on the leakage tester until it reads 0. After that, you would install the hose from the leakage tester into the spark plug hole. And in this way, you would record the amount of leakage. Now, what's a good reading and what's bad? Say, for example, we have 10% leakage. That's okay. There will always be some leakage, especially on a brand new engine where the rings aren't seated yet. It's even possible you could see up to 20% cylinder leakage. But if you start to see 30 and 40%, then you got a problem. So refer to the appropriate shop manual for individual leakage specifications. If you do have excessive amounts of leakage, the next step would be to find out where the leakage is. If it's leaking past the exhaust valve, air will be coming out of the exhaust. Past the intake valve, and air will be coming out of the carb or the throttle body. If it's leaking past the rings into the crankcase, air will then be rushing out of the crankcase breather hose, which is here. Now, leaks from these three areas are best detected by simply listening. If the head gasket is leaking into the coolant jackets, bubbles will be coming out of the radiator or the coolant tank. Ensure that you have the cap off before you start the test. Through the head gasket into the crankcase, you would have a very milky oil. And if it's going through the head gasket into an adjacent cylinder, air would then be coming out of the adjacent cylinder spark plug hole. So after you determine where the leak is occurring, then you can determine what to repair. Now, what would you do if, say, a person came in with a complaint about the oil light being on, or maybe some knocking or tapping sound? Well, the first thing you'd want to do is check the oil level, and then you'd do an oil pressure test. So check the oil. If that's fine, then it's on to the oil pressure test. Let me get my gauge. In order to obtain accurate oil pressure readings, the following steps must be taken. First, you need to locate the oil pressure tap. Here's one here. Now, in many cases, the oil pressure sending unit, like the one we have here, would be removed and its position would be utilized for your test. Refer to the shop manual for the recommended checkpoint. Then you would install your oil pressure gauge. After that, start the engine and record the reading. Next, allow the engine to reach operating temperature and record the reading again. Finally, you would compare that reading to the specification listed in the shop manual. Now, let's talk about some of the causes of low oil pressure. Let me just get a couple of parts out here. It could be caused by any of the following. a worn oil pump. The camshaft or crankshaft could have excessive bearing clearance, or there could be a weak or broken oil pressure regulator spring. The pressure regulator could be stuck open as well. Now, you may also have a clogged oil pickup screen, which on this model is located here. Or there's the possibility of an air infiltration into the oil pump inlet. And finally, you could have excessively diluted oil. So take an oil sample before you disassemble the engine. Now, in the case that you have too high an oil pressure, it could be caused by the pressure relief valve being stuck closed. If the oil pressure is good, but say there's a noise, there are many items that could cause this. Remember that there are many parts to a four-stroke engine, so try and isolate where the noise is coming from before you attempt a disassembly. To do that, you might want to use a mechanic's stethoscope, like I've got over here. And what you would do is just place the probe on different parts of the engine in order to isolate the noise. And here, and also down by the crankshaft. Now on different engines, you need to check different spots. Say here and here. And that'll give you a pretty good idea of what's going on inside the engine. Now, if you don't have a mechanic's stethoscope, you can go the old-fashioned way and use a screwdriver. Place it where you want to listen and put your ear against the tip, and you can probably be surprised how much you'll hear that way. Now, in the case of a knocking noise, if it's possible, you can try to verify if the noise cycle follows the speed of either the crankshaft or the camshaft, because since the two are timed differently, the camshaft rotates at half the speed of the crankshaft. This will give you a pretty good idea of which part of the engine that the noise is related to. Now just remember that with a little strategy and the tests that we've just covered, you should have no problem diagnosing four-stroke engine issues. And that's all I wanted to cover for four-stroke engine diagnosis, and we'll see you in the next chapter.